Good afternoon. Today we will discuss about that. Our topic is gas dynamics and jet propulsions. Gas dynamics means the gas is the enter into the combustion chamber nozzles. What are the properties of changes, and the gas is used for the turbine is used for the jet propulsions. These are we will discuss in today's topics. The jet propulsions almost is used for the passengers, then aircraft vehicles, then rocket propulsions. These are the things are used for the gas dynamics concept. Then some others, what are the objectives of this gas dynamics and jet propulsions? The jet propulsions we have major concentrate about these topics. Our objectives of these topics is what is the jet engines, what are the describe the Newton's second and third laws, how to implement in these jet engines, then what are the applications of the jet engines, what are the key points, then advantages, then disadvantages, then working principles of the jet engines we will discuss about. Next, the jet engines means the various things are discussed about the previous classes. The jet engines means the gas is entered into the combustion chamber, then turbine, then the exhaust gas. The exhaust gas is released in the turbines. The thrust is produced. The concept of thrust is based on the principles of Newton's third law. The principles of the Newton's third law, every action is equal to opposite reactions. These are the things the thrust is used. The thrust is produced for every action. There is an equal and opposite reactions. Based on the Newton's third law, the jet propulsions we have for working for the jet propulsions. Then next one, the Newton's second law for the applicable for the jet engine propulsion. The force of an object is equal to its mass times its accelerations. These are the things. The same principle is also used for the rocket and the jet propulsion engines. This is the schematic diagram of the Newton's third law. Is how to works for the Newton's third law. The fuel and the oxygen is entered into the combustion chamber. The combustion chamber, the fuel is burned. After the fuel is burned, is passing through the nozzle. The fuel is the high velocity gas is produced for the nozzles. The nozzles of the applicable for the Newton's third law. The high velocity gas is entered. Which forces the opposite reactions, the thrust force is produced. The thrust force based on this, the various jet engines used in the commercial Boeing 757 jet propulsions. Then military business and the personal jet, these are the things. Next, the military fighters, the rocket propulsions is also used. These are the things. Then what are the concept the jet propulsions are working? The introductions about the jet propulsions. The jet engine is nothing but the gas turbines principles. The air is, this is the schematic diagram about the jet engines concept. This is the fan, then this is the compressor, then this is the combustion chamber, then this is the turbine, then this is the nozzle, this is the expanded the gases. These are the things for the use for the jet propulsions. This is the various types of jet engines: turbojet, turbofan, turbo propeller, pulse jet, then ramjet engines. This is the one type of jet engines. Parts of the jet engines: the fan, compressor, combustion chamber, combustor or turbine, then the nozzle. These are things. The one engines we will discuss the elaborated the working principle. The turbojet engines. The turbojet engine is the reaction engines. The air is entered into the low pressure compressor. The low pressure compressor is the atmosphere. Air is entered into the low pressure compressor. The low pressure compressor, the compress the air. The air is they expand the pressure and the velocity is also increased. The low pressure compressor, after the leaving the low pressure compressor air is entered into the high pressure compressor. The further compressed, the air is the high pressure, then high temperature is also increased. The high pressure compressor, high pressure air is passing through the combustion chamber or combustor or burn. The high pressure air, then the fuel is injected into the injector. The high pressure air, then the fuel is mixing with, then the fuel is burning. The fuel is burning. After that, the fuel is burning, the high pressure the exhaust gases is passing through the high pressure turbine. The high pressure turbine is to the high velocity is also increases. Then after leaving the high pressure turbine, the gas exhaust gas, the low pressure turbine, the velocity of the gas also increases. Then the last one, the nozzle is the low pressure turbine exhaust gases is passing through the nozzle. The nozzle is also injected into the high pressure, the high velocity gases. From this, based on this, the high velocity, high pressure gases, the automatic based on the Newton's third law, the thrust is produced. The thrust is produced with the turbojet engines or jet propulsion is moving in the forward directions. Is also applied into the rocket propulsion engines. The rocket means without the acceleration, only there is no atmosphere here, only the combustion chamber, the fuel is burning in the oxygen fuel. This is also applicable to the rocket propulsion engines. Is the turbojet engines is nowadays changed for the various methods, the turbo propeller, turbo fan, then first jet engines, the various forms, the velocities, then based on the speeds we have selected for this the jet propulsion vehicles. Thank you.